So, we're going to pick up yesterday where we left off talking about alternating series, and then we're going to continue, learn more about sequences and series. We're almost done with this section, and then we're going to be moving on to something new using the series. So, exciting times, exciting times. Let's do this. Okay, what happened? Okay, there we go. Oops, let me rearrange my camera. There we go. Okay, so last time we learned about the alternating series. And it's basically what they are is a series that like switches the sign back and forth, positive, negative, positive, negative. And I told you that there's basically two ways to represent this. There's the case where it goes negative to positive, or there's the case where it goes from positive to negative. It doesn't really matter, just you should be aware that there's two of them. It's important to remember that if you have -1 to the n, it's gonna start off as being negative, but if you have -1 to the n plus 1, it will start off being positive. So if you're ever like making an alternating series, that's like something you should think about. Okay, and then it's important to remember that when we're talking about an alternating series, we'll have that -1 to the something that will make it positive or negative, and then you have what the book is calling Bn. That's like the terms, but they're only positive. The -1 is the thing that changes the sign. Okay, and we found out that if you look at those Bn's, the part without the negative, then you know the alternating series will converge if they're always decreasing and if their limit goes to 0. So we did some examples with that yesterday. Okay, so we're gonna continue today and talk about what the book calls the remainder of an alternating series. Oh, my nose feels weird this morning. Or today. Okay, so let's say that you have your alternating series. Oh! Now? Okay, there we go. My bad. I did not have myself spotlighted, so if there was any like noise coming from anyone's mic, or if they joined the meeting, then it would default to them. Thank you for reminding me. So you just heard my voice talking and you're like, don't know what's going on here. Sorry about that. Okay, so we have our alternating series, which is either going to be, as I was saying earlier, -1 to the n, which will start off negative with your Bn. Or a series from 1 to infinity of -1 to the n plus 1, which will start off being positive, and then the Bn. Okay, and let's say that this satisfies the alternating series test. So in other words, we know that it converges. Okay. So let's say that S is equal to whatever it converges, and then S big N will be the partial sum. Okay, so you know an interesting thing, a fact that will help you estimate what the alternating series converges to. So we're going to call Rn the remainder of S minus Sn. So in other words, what is this? This is the oops, why is it not letting me type? This is the difference or remainder. Okay, this book is pissing me off. Okay, 1 second, I need to like readjust my keyboard. The difference between the infinite and partial sum. So to remind yourselves, remember that if you take the limit of the partial sums, that's going to be equal to the infinite one, right? So the remainder is basically telling you, like, okay, well, as those partial sums converge the remainder tells you, as those partial sums converge to the value of the infinite sum, how far away is that partial sum from the infinite sum? In other words, the difference between where they're heading to and where they currently are. And the alternating series has this nice fact that that the absolute value of the difference between the series and the partial series has to be less than or equal to b big N plus 1. Okay, and so I'll show you like how do you actually use this. So the idea is if you were able to calculate the infinite sum and then you calculated the nth partial sum, the difference between them is less than the nth plus 1 term. Okay, so let's do an example to use this. So how would you use this, like, in an actual example? So example, let's estimate the difference between between Sn or S10, the 10th partial sum, and the series, the actual amount. Okay, so for this problem, the infinite sum that we would like to estimate is n equals 1 to infinity of negative 1 to the n plus 1 over n squared. Okay, so how does this work? Well, we know that the difference between S, the infinite sum, and S10, the 10th partial sum, we're going to call that R10. It's the remainder between the two of them. Let's type that down. So this is the, why is it not letting me type? The remainder slash difference between the infinite sum and the 10th partial. Okay, so the result that I had above tells us that, oh, well, the absolute value of that remainder is going to be less than the 11th term. Because in this case, my big N is 10, the 10th partial sum, and the formula said the nth remainder is less than or equal to the nth plus 1 term, so that's going to be B11. So our Bn is negative 1, or sorry, not negative 1, is just 1 over n squared. So what is B11? B11 is 1 over 11 squared, which is 1 over 121, which if you calculate it is, let's find out, oh my gosh, it's like not letting me type where I want to type, and it's like really pissing me off. There we go. 1 over 121 equals that number. Okay, so what is this telling us? It's telling us if we were to calculate S10, right? So S10 is at most differing from the value of the infinite sum S by 0.0083. Okay, so what you could now go do is you can go and calculate S10. You can say, hey, what's the sum of those first 10 terms? Right, so you'd have B1 minus B2 plus B3 minus B4 plus B5 minus B6 plus B7 minus B8 plus B9 minus B10. If you were to actually calculate that, that number would only be differing from the infinite series by at most that much. Okay, so this is basically useful for you to be able to figure out, like, oh, I'm unable to. Let's say you were unable to figure out what this amount was, the infinite sum. This now gives you a good idea if, well, how about I just calculate S10? Like, at worst, how much am I off by? And that's like a pretty small amount, so maybe that would be acceptable given, you know, whatever constraints you have. They do this a lot in engineering. So, like, does it make sense in engineering that you want to, like, simulate, like, say how an engine works or something like that? Actually, this is a really interesting thing to talk about. Let's talk about it. Okay, how does, like, an engine work? Like a internal combustion engine, the standard one that we're used to. So, like, how does the internal combustion engine work? Does anyone know? Oh no, I've lost everyone. Was it in this class? Oh, lots of little explosions. Yes, that is true. So, but like, there's this tube, and inside this tube, there's a disc. Okay, and then when the gas explodes, what happens to the disc? Yeah, it pushes it down. Or yeah, depending upon where the explosion is happening. Usually you have the gas in and the vent out up above. So yeah, usually it would push it down. And then that thing is... no problem. That thing is connected to a flywheel that turns, right? And that's what actually makes everything spin. Right, so like as that thing goes up and down the piston, as the disc moves up and down the piston or whatever it is, it's connected to a thing that makes it go like this, right? Now, oh my god. Someone take out Burrito, please. So, sorry, Burrito's here like looking at me and so he wants to be taken outside. So, oh, I knew it. He's gonna start barking. Okay. Back to this. Okay. Dog. Shh. So, they actually simulate how those explosions go down. Now, does anyone have any idea about like how many air particles you have to simulate like of the explosion to get a good idea of how this works? Like, how many air particles might you need to simulate the effect of? Like, because the heat, which causes the air to expand, which pushes the piston. Like, any idea? Okay, wait, I just need to tell my children. Someone should take Burrito out. Cool, can you do it afterwards? Burrito, come here. Okay, there we go. They have Dogecoin in Discord. Okay, so there's a bunch of air particles, and like what happens is they'll pump in gas right here. There's like an air inlet, and there's a gas inlet, and then there's a exhaust outlet. So they put the gas in, and so there's like a little spark plug, right? and there's a little thing. So the gas goes in, and the two meet, and it explodes, right? Now, any idea like how many particles you need to simulate? Like if you think about like if you were like some sort of deity and you could just like look at the Ijid, you would like see all these little explosions happening. Like if you could stop time and stuff. Like any idea the number of molecules that we're talking about? Like the gas molecules, the air molecules, billions, yes. There are literally billions of things to simulate. So does it make sense that this is practically infinite, like as far as we're concerned? And to run the simulations, they actually calculate integrals. And the way they calculate the integrals is using series like this. So if you don't want to calculate a practically infinite amount, you need to choose what your partial sum is going to be to come up with a good enough estimate. And does it make sense that you then need to have an idea about how wrong your estimate may be to decide if you need to increase the number of molecules that you're simulating in your simulation because you want to bring the error down? Like, there's no point in simulating this, like, you know, these explosions happening on the computer if it doesn't actually give you good information about what happens in real life. Okay, so like this is like, so I guess what I'm trying to like bring across here is that like these sorts of things like are actually pretty useful in terms of how the math is actually used. Hopefully I'm getting that across to you. I find it really interesting. There's a lot of cool videos you can watch online about like by engineers and physicists and people who like do this stuff for a living, and they actually talk about it, and it's like, it's intense. I find it really cool. Okay. So, let's go on. So now there are two types of convergence that we're going to be interested in. So there's something called absolute convergence, and there's something called conditional convergence. Okay. So let's say that you have a series, an infinite series of the sums of an. Okay, we say that that series absolutely converges if, when you take the series and make all of the terms positive, in other words, you put absolute value around them, that if that still converges. So a series is absolutely convergent if, when you make all of the terms positive, it still converges. We would say that the series conditionally converges if this one converges, but when you make everything positive, in other words, with the absolute value, that diverges. Okay. And important to know, if the absolute value of the terms converges, then this will have to converge. Okay, and we'll look at some examples. Okay, so it's called absolute convergence if, when you take the absolute value of the terms, it still converges. It's called conditionally convergent if your original series converges, but when you take the absolute value of the terms, it diverges. So let me show you like some examples of when this happens. So let's figure out whether it converges absolutely or conditionally or whatever. So let's look at the infinite sum from 1 to infinity of -1 to the n plus 1 over 3n plus 1. Okay, so let's first of all just figure out if this converges. Okay, so let's use the alternating series test. Okay, so what does the alternating series test tell us? We need bn plus 1 to be less than or equal to bn. Okay, remember, in this case, the bn is the part without the -1, so you get 1 over 3n plus 1. So bn is 1 over 3n plus 1. bn plus 1 means that you replace the n with n plus 1, so you get 3 times n plus 1 plus 1, which is 1 over 3n plus 4. Okay, why do we know that this is true? Well, because if you look at the denominators, which of the denominators is larger? 3n plus 4 must be bigger than or equal to 3n plus 1, which means when you take their reciprocals, the inequality switches. So yes, this is true. It meets this criteria. Okay, what's the other criteria? You need the limit as n goes to infinity of bn to be equal to 0. Well, the limit of n goes to infinity of bn is 1 over 3n plus 1. That definitely goes to 0 because you get infinity on the bottom. So we also meet this criteria. Okay, so far we know that our series converges. Now it's a question of, does it converge absolutely or conditionally? Okay, what will it mean to converge absolutely? It converges absolutely if, when I do the series with the absolute value, it still works. It only converges conditionally if, when I do the absolute value, that it diverges. So now we need to figure that out. Because we know it converges, the question is whether it converges absolutely or just conditionally. Okay, it will converge conditionally if, when you take the absolute value of it, it diverges. It will converge absolutely if, when you take the absolute value, it still converges. Okay, so what we need to do now is take our -1 to the n plus 1 over 3n plus 1 and just take the absolute value. Okay, and now we can do the absolute value of the top and the absolute value of the bottom. Okay, what do you know about the absolute value of -1 to the n plus 1? What will that always be equal to? So looking at this top part right here, yeah, it's just going to be 1. Because it was -1 and +1 flipping back and forth, the absolute value of that will just be 1. Now, luckily, because n is greater than or equal to 1, 3n plus 1 is always greater than or equal to 0. So when you take the absolute value of it, the absolute value symbols just go away. Okay, so now we need to figure out, does this converge or diverge? Because I took the absolute value, you get that, that's why that's there now. Okay, so what we're going to do is, how about we do a comparison test? I am going to compare 1 over 3n plus 1 to 1 over n. Yeah. Oh, wait, that's not how you do the comparison test. Jesus. So we're going to compare our bn, which equals 1 over 3n plus 1, to our an, which is going to be 1 over n, because we know this thing diverges. Okay, how does the limit comparison test work? If you want to do the limit comparison test, if you want to compare your two series, what do you... Oh, because I want to figure out what happens to 1 over 3n plus 1. Does that make sense so far? Okay, so I need to compare it to something, and I'm just choosing something that I know diverges. Does that make sense? Because I have a feeling 1 over 3n plus 1 diverges. Because, to be honest, the way it works is you look at the highest power, like a p-series, that's 1 over 3n to the first plus 1. That's a p-value of 1, and what happens if your p-value is not bigger than 1? You diverge. Yeah, so I'm going to compare it to something that I'm like, I bet it's like 1 over n, I bet it diverges. Does that make more sense? Yeah, so usually if your bn is 1 over n to the p plus other shit, you should probably compare it to 1 over n to the p. Look at the highest power. That's actually a really good question to ask because it's hard to notice that. Okay. So, limit comparison test, what do? I take the limit of what? If I want to do the limit comparison test, what do you take the limit of? Do we remember? So for that limit comparison test, what? Yes, an over bn, awesome. So you're going to take the limit as n goes to infinity of our an is 1 over n, our bn is 1 over 3n plus 1. Burrito, leave me alone right now. So we get 1 over n divided by a fraction, so we can multiply by the reciprocal. So we're going to get 3n plus 1 over 1.
Sit down. Up. Up.
So we're going to get 3n plus 1 over n. And when you take the limit of that, what are you going to get? You're going to get 3. And now here's the thing. You have to remember the limit comparison test says that if when you take the limit of this and you get L and it's not 0, then what happens? They both converge or diverge. Well, no, it diverges because the 3 tells you that they converge or diverge together, and what sort of thing did I choose to compare with? Something that diverges. Well, because AN diverges, BN also diverges. They have to converge or diverge together. And then because I got something not equal to 0, I know that the other one also diverges. Because I don't know if this one converges or diverges. So I call that my BN. So I compared it to something which diverges. The limit comparison test tells me now that this one also diverges. Wrong thing. You're thinking of the P series. That's where P is a power, not a coefficient. Yeah. No, actually, I've been having a super rough time recently. Like, my headache is only finally going away. I think I told everyone that I took like 2 ibuprofen like before class started. It is like so hard to keep track of stuff sometimes, and also like, you know, there's like, I'm just gonna like rant for a little bit. Like, does anyone just have days like Burrito right now is like begging for food, and like I'm in the middle of lecturing, and like my mind just like constantly going off on a tangent. I'm like sort of angry at him. Like, yeah, you know, like you just get to this place where it's like there's all this little stuff in your day where you're like, I can't think about this right now because like I didn't eat, or I have a headache, or, you know, my dog's whining or something like that. Like, I feel bad sort of ranting to you, but like at the same time, I understand that you guys have like, you know, the same things going on in your life sometimes. So like, don't ever be afraid to like ask a question. Like, obviously I may not be able to give you an answer, or you might not be in a space to hear it. But like, I totally get what that's like, you know, to be like, wait a second, like I thought. Yeah, there's so much stuff to do and there's so many distractions because we're at home, right? You know, there's like all the home stuff going on. So yeah, I mean, end rant, I guess. So hopefully you can see how this works. So because this series diverges, we now know that when we took the absolute value of it, it diverged, which means that the original series was conditionally convergent. So the original series was conditionally convergent. Why? Because, I'm trying to get the sum thing. Oh, there we go. Because the sum of AN converged, or because the sum of BN converged, but, oh fuck, I accidentally closed the window. Sorry. The original series was conditionally convergent because the original series converged, but when you looked at whether the absolute value of the series converged, it diverged. But yeah, so much for... Yeah, so what I mean is, let me write it in. Which one converged? The sum of n equals 1 from infinity of -1 to the n plus 1 over 3n plus 1. That converged. But then when we took the absolute value of that, which ended up being the same thing as looking at the sum of just 1 over 3n plus 1, that diverged. So we already knew that our original series converged. The question now is, well, what about when you put absolute values around the terms of the series? That diverged, and that's what makes it conditionally convergent. It was convergent. The question is, what type of convergent? You're only conditionally convergent if when you take the absolute value, it diverges. You're absolutely convergent if when you take the absolute value, it still converges. And we'll do an example. No, I mean, thank you, Michelle. That means a lot to me. I try really hard to sort of explain it the best I can and not just do the calculations. I want you guys to like actually understand. That's like always my goal. So I'm happy. I'm also, I am very pleased with everyone. I know it's like been hard. Once in a while, the rents are listening to. I know it's like really hard to like learn stuff like at this time, especially. If you're working, if you have family problems, people are getting sick, you have kids, all that stuff. It's just part of life. Yeah, dogs want food. Well, actually, he wanted to be taken out, and it's like I obviously can't just take him out right now. And my kids are on break, so like normally I'd be waking up earlier in the day, but it was Friday, so I woke up at like 8. And like I took him out a while ago. And then, usually there's like everyone's sort of like taking him out, but because they're on break, everyone's just sort of lazy this week. Oh, it's cool. Nice to move to applied math. Alright, let's do another one of these. Example, does the series diverge, converge conditionally, or converge absolutely? Okay, because there's two types of converge is what we're learning here. You can converge conditionally, or you can converge absolutely. So let's look at the sum of n equals 1 to infinity of, where'd my example go? The cosine of n over n squared. Okay, so first of all, we have to figure out whether this converges. Oops. Ah. So if this is your an equals cosine n over n squared. What did I tell you the rule was for choosing something to compare it to? If you wanted to compare, what was like my tip? Yeah, so do you see how you have that n squared on the bottom? We should compare it to just 1 over n squared. And actually there's a good reason for doing this, because what do you know about the cosine of n? What is it always less than? Yep. And what is it always greater than? And something else slightly smaller. It always goes between negative 1 and 1, right? Which makes sense why I could just sort of forget about this and end up with a 1 here. Because that cosine is always going to be less than that. So you can like sort of disregard it. Okay, so let's do the comparison test to figure out whether this thing converges or not. So you do the limit as n goes to infinity of an over bn equals, your an is 1 over n squared, and your bn is cosine n over n squared. Oh shit, I forgot to write the limit. Move that over. So I've got the limit as n goes to infinity of this. So we do some algebra, limit as n goes to infinity of, we've got our 1 over n squared, and we multiply by the reciprocal. So now you're going to get n squared over cosine n. And then, oh my god, look what happens. Those n squareds, they go away. Which leaves you with the limit as n goes to infinity of 1 over cosine n. Okay, wait. Okay. Okay, and then this actually is going to be undefined. Okay, is that actually going to work for us then? What happens in the comparison test when you get undefined? You don't get anything. I did flip AN and BN, thank you. But I think that won't make any difference because you're just going to end up with cosine n and that's still going to be undefined. That's still going to be undefined. Okay, so that didn't really work. Okay, we'll leave that there for a second. I have another idea that I'm going to quickly run through. I think what we need to say is the cosine n over n squared is going to be less than 1 over n squared. Oh, there we go. Okay. What do we know about this series? Does it converge or diverge? This one converges by p-test. Now, if this one is less than something that converges, then what can I say about that one? Hence, it also converges. Yeah, there we go. Okay, cool. So we know that this converges. We can cross out the possibility that it diverges. So now the question is, does it converge conditionally or does it converge absolutely? Okay, so does that sort of make sense to everyone? Like, we know that this series converges. We now wonder what sort of convergence we're dealing with. Okay, and then we didn't have to use the limit comparison test. We just used the comparison test. Okay, so I just want to pause. Does it make sense to everyone that we've excluded that it diverges? We know it converges, but we've complicated things by saying that there's two types of convergence now. Like conditionally convergent, absolutely convergent. And the reason we know that is... Yes, because that's actually... What made me think of that was I had said this up here. I was like, look, we actually know that cosine n is always less than 1, so we get to this step really quickly, right? Because it's less than it, and the bigger one converges, boom. Yeah, well, okay, if there was 2 cosine here, what could you do with this 2? But I could move it out and then I could disregard it. And then you could still do the comparison. So that is a very good question, Matthew. Like having the constant there actually doesn't change anything because you can always factor out the constants. Okay, so now we have to ask ourselves, okay, does this thing converge absolutely or not? So now the question is, does this converge absolutely or conditionally? Okay, so what we have to look at now is the infinite sum of the absolute value of the cosine of n over n squared. Okay, now here's the interesting thing. What we did before still is going to work here. Is still going to work here. Because the cosine of n over n squared, that is equal to the absolute value of the cosine of n over the absolute value of n squared is just n squared. And what can you say about the absolute value of cosine n? That's still less than 1. Okay, and 1 over n converges by the comparison test, we now also know that this thing converges because it's smaller than something which converges. So we now know that we absolutely converge. Why? Because when we put the absolute value, this still converges. Okay, I'm gonna oops, what happened? I'm gonna scroll up so you can see the whole thing as much as possible. So we know that it absolutely converges. It is not conditionally convergent because when we put the absolute values around it, it still converged. Ooh. Okay. We have finished the alternating series section. I think this is a good place to end on Friday.